Welcome back to the Spicy 100. This is question 17. The recommended time for this one is 5 minutes. It is a non-calculator question, so I'll read it to you. A quadratic function, y equals f of x, has a maximum point at -3, -5, that's a coordinate, and intercepts the y-axis at the coordinate 0, -9.5. Find an equation for y in terms of x. So have a good read of the question, and when you're ready, set your timer for 5 minutes, pause the video, and best of luck with question 17. So we're trying to find a quadratic function, so y equals f of x. We're trying to find y in terms of x, and they've given us these two coordinates, -3, -5, which represents a maximum point, and intercepts the y-axis, so the y-intercept is at 0, -9.5. Find the equation for y in terms of x. So the general form of a quadratic we could have is y equals ax squared plus bx plus c. So where a, b, and c are our coefficients. So a is the coefficient of x squared. So this is the very general form of a quadratic equation. If you remember the quadratic formula, that's how we sort of separate our coefficients to use that. Because we're trying to find a quadratic and they've given us a maximum point, there's actually an alternative way. And if I use some different letters, so p x plus q squared plus r. So this is actually in the format of if you do completing the square to your quadratic, but this actually helps you to find the maximum or minimum point of a quadratic. So in this case, it's a maximum. And actually from this, you could find the maximum here would be -q r. What I'm going to do is I'm going to show you this on Desmos so we can get a sense about how this form of quadratic works, and then we can use it to find out our p, q, and r, and then we'll have an equation for our quadratic. So this is Desmos. It's a free graph sketching software. I really like it for seeing what graphs look like, and you can do this thing where you can add in sliders to see how these graphs behave. So what I'm going to do is I'm going to type in that general form, y equals p, open bracket, x plus q, close bracket, squared, plus r. And see it has this option to add sliders for all three of these, so I'm going to press all here. And then what you can see is you get a quadratic, and you can see here that so because p is 1, q is 1, and r is 1, so that's where they are in that function. And you can see here that actually the minimum point is at -1, 1. So if from the q, we take the negative of that value, and the r is that value. So what we can do is I can actually move this around. So if I move q, you can see that as I increase q in the positive direction, it moves in the negative. So that's the x coordinate of the vertex. And r is going to move it up and down. So for example, if I make r 4 and I made q -2, you can see that the minimum point is now up by my head, but we've got 4, 4. So if I can move r down, I can move this way. And then the p-value, all that does is it kind of affects how steep the curve is. So if I make p larger, you can see it's getting steeper, but it's not affecting the minimum point. So the minimum point stays the same. Now crucially, I'm just going to move this up a little bit. If I make p negative, you can see that negative p actually gives us a maximum coordinate. So if I make q, say 3, and r 2, so we've got a maximum value at -3, 2, so it's the negative of the q. But you can see that because p is negative, this is actually a maximum value. It gives us this sad face negative quadratic shape. So negative gives us a maximum, and then positive gives us a minimum. So that's how we're going to use this to find the specific equation for our curve. So let's go back to our working out. So because our equation has a maximum point, this actually means that this p-value we know is going to be negative. But I'm going to start with the q and the r. Because we know the maximum point is -3, -5, we actually already can fill in most of the details here. So I could say that y is equal to p x. So because it has a maximum point at -3, -5, that must mean we're going to have +3 here and -5 on the end. So reading from here, so knowing about when you get maximums and minimums, your vertexes to a quadratic, this would give us one at -3, -5. So that only leaves us with one constant p to find out, and then we can use the other coordinate to do that. So because we have this coordinate 0, -9.5, and remember this means that the x value for this coordinate is 0 and the y value is -0.95, we can actually put these into our equation and we can find the only remaining constant that's missing, p. So we put these in here. So we'll get -9.5 is equal to p multiplied by x plus 3, so that's 0 plus 3 squared, subtract 5. So what we're going to get is -9.5 is equal to, so we've got 3 squared, so we've got 9p, subtract 5. We're going to add p to the other side, so -9.5 plus 5 would be -4.5 is equal to 9p. So p is going to be -4.5 divided by 9, which is -1/2 or -0.5. And that's going to be your p. So bringing the whole thing together, our final answer, so our y is going to be equal to -0.5 open bracket x plus 3 squared subtract 5. If you double check that, if you sub in x is -3, y would be -5, and if you sub in x is 0, then you would get y to be -9.5. So it works. So this equation required us to be confident about maximum and minimum points, how they completed the square version of a quadratic. We can use that to find the vertexes. Needed to be confident with subbing coordinates in and the shape of quadratics. I hope you enjoyed question 17. If you're feeling confident, why don't you move on and have a go at question 18. If you're enjoying the Spicy 100 series of extra fiendishly difficult GCSE Maths questions, please do subscribe to the Hench Maths channel and like the video.